Students, welcome to my channel Math Excellence. Today we are discussing one of the another test, which is chi-square test. In my last videos, I have discussed with you about the Z test and T test. What are the conditions for Z test and T test? How you can check that this test is applicable on Z test, and what are the conditions that to see that this on this data on this type of problem I need to go for Z test or T test. So similarly today I'm discussing about chi-square test. So let's start about this. For chi-square test, the major or primary I can say that the condition is it is applicable on categorical data. Categorical data, now what? Suppose you are going a restaurant, you have ordered something, okay? So you will get options. Suppose you are getting option, is it good? Is it very good? Okay, the food is average, okay, and the food is bad. You are getting these categories. So this type of data belongs to categorical data. One more example, suppose in a class students are failed, got first position, second position, third position, categories you are saying. So this type of data is a categorical data. So on these type of data, we always apply a chi-square test. One more condition we have for the chi-square test. Chi-square test is always applicable. Suppose you have some observed data. Observed data means students, data is given to you. Now, by taking some hypothesis, by some experiments, formula, you got a expected data. Correct? Now you have a observed data and expected data. When you want to check that how closely they are related to each other, how close they are, you want to check the you want to check how they are closely related to each other. This is called goodness of fit. So if you want to check goodness of fit between observed and expected data, we always use the chi-square test. So we have two conditions for chi-square test. For the categorical data. Second, to check observed data and expected data, how closely or how much they are close to each other. When we want to see, we always apply chi-square test. So you can see a statistical method used to determine goodness of fit. Goodness of fit means how closely observed and predicted data is. Okay. One important note we have, guys. Chi-square test we do not chi-square test never check the hypothesis correct or not. Like in Z test, T test, we always see at the last when we take decision ki we should go for null hypothesis or we should not go. But in chi-square test, we never check hypothesis correct or not. We just evaluate and we check that how like what is the goodness of fit. That now the process in chi-square we have first of all take null and alternative hypothesis, find critical values and apply the chi-square test. This is a formula student for the chi-square test and this is not x. It's a notation that this is the notation of chi-square. Please keep remember this is the notation of chi-square. The formula of chi-square is OI minus EI upon EI. And in many books, they are using FI minus EI. That doesn't matter. Both have same meaning. OI means observed, what is given to you. EI means expected. Same FI means observed. EI, we know this is expected. Okay. And conclusion, same. If calculated chi-square less than tabulated value, accept the hypothesis, otherwise reject the hypothesis. Okay. Just keep remember students when you are going to check the goodness of fit, when observed data is given, you want to find the expected data. So we always go for the chi-square test. Now, this is a table for the chi-square test. in exam you always get this table, okay, and you can see that these are the degree of freedoms and these are the level of significance. Usually we always go for alpha is equals to 5%. You can also write in 0.05. Okay. Now let's start the first question. First question is the following figures show the distribution of digits in number chosen at random from a telephone directory. Now from a telephone directory they have chosen some of the numbers which are from 0 to 9. Okay, 0 is coming how many times? 1026 times, like similarly 1, 2, done. You have to test at 5% level whether the digits may be taken to occur equally frequently in the directory. Means these digits you are taking from the directory are they equally likely coming in the directory or not? You have to see this one. So class, now you can see nothing, no sample is given to me, standard deviation, nothing, only a one data is given to me. Correct now? So when you see this type of thing, so definitely in your mind it should come that no sample, standard deviation, all the things less than n, sorry, n is not less than equals to 3, n is greater than equals to 3, nothing is given, only one data is given to me and this is observed data. Now this is the observed data. So definitely if observed data is given to me, what I should do, which test I need to apply? Chi-square. So it's very simple in the exam. By looking this condition, you can see that definitely I have to go for the chi-square test. First of all, take the null hypothesis. Null hypothesis means whatever is given to you will go accordingly. So you will say this thing, the digits may be taken may be taken to occur same like equally frequently in the directory. We will write over here same thing. And a hypothesis, same thing, but the digits may not be taken. Rest of the things will be as it is. Because chi-square test will not check your null hypothesis. It will just calculate or evaluate your observed data. Okay, shall we start now? How to check? Now, okay, already I have told you never learn the table guys. You have to always learn the formula. Okay, what is the formula of the chi-square? Summation I is equals to 1 to a observed minus expected whole square divided by expected. What is given to me? First one was digits. Digits. That is 0, 1, 2, 3, 4. Please solve this question with me. 7, 8, 9. Okay. Then next is frequency. Which type of frequency? Observed frequency. So what is observed frequency? We have 1026, 1107, 997, 966, 1075, 933, 1107, 972, 964, 853. Okay, and if you will go for total is 10,000 of these numbers, of these frequencies. Now I need to calculate expected frequency. How to calculate expected? Now listen to me carefully, guys. Expected means total of observed frequency divided by how many total terms we have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 terms I have. So what is my expected frequency? I'm expecting that definitely 1000 term, 0 is coming 1000 times, 1 is coming 1000 times. Same for 3, 4, 5, 6, 7, 8, 9. Okay, so expected frequency for all the digits will always same. Keep remember that. Now, what is in the formula? See in the formula, no need to learn the table, see the formula. What we need? EI we got, yes, 1000. What we want now? Observed minus expected. Calculate observed minus expected. 1026 minus 1026, then 107 minus 3 minus 34, 75 minus 67, 107 minus 28 minus 36 and minus 147. Done. Now what we want? Observed minus expected whole square. So what is it? 676, 26 square, 11449, 3 square, 9, 34 square, 1156, 75 square, 5625, 67 square, 4489, then 107 already we solved, 11449, 784, 1296, and 21609. That in the last we want, you can see observed minus expected whole square divided by expected. So 676 divided by 1000, obviously 0.676, 11.449, it's 0.009, it's 1.156, 5.5, sorry, 5.625. Please check the calculation with me and solve this question with me. 11.449, 7.84, 12, 1 point, sorry, it's 1 second. It's 1.296 and 21.609. Total of these values is 58.542. So what is the chi-square we got? Chi-square is 58.542. Now if you want to basically in chi-square we never check that hypothesis is correct or not. Okay, I got the answer 58.542. This much they are close to each other. But in case if you want to check, so how you can check with the help of table? Yeah, definitely we can check. We cannot say chi-square do not prove. Basically, it's do not prove. But if we have the table of chi-square, we can cross verify and we can check it. How? Now I'm telling you. If you suppose if you want to check at 5% of level of significance, at 5% level of significance, correct? Okay. What is the value of n here? N is 10. So what is degree of freedom? I have discussed in my last class also, n minus 1, which is 9. So see over here, degrees of freedom, it's 9. 5% level of significance. What is the value? This is the value. So it means that my table value of chi-square at 5% level of significance is 16.919. So you can see my calculated is greater than tabulated. So definitely I have to reject the null hypothesis. Question is done. So any question in which observed data is given to you, you can solve by using the chi-square test in this way. Okay, this is the same question class. Number of days and observed frequencies given to you, right? Total is this one. In this question, again, if you're applying the chi-square test formula, observed minus expected whole square by expected, how to calculate expected? Total of observed divided by number of terms 1, 2, 3, 4, 5, 6. It's 6. Okay, you will get the expected frequency. So try to solve this question by yourself. Take it as an example, solve it, and in comment box, please mention the solution of this one. So what is the value of chi-square you are getting? You should go for rejecting the hypothesis or accepting the hypothesis. Again, one different example I'm discussing with you now. Now this is a different one because in the first example I have discussed when observed data is given to you. Okay, now in that example, observed data was given in a format of table, but here is no table. How to solve? So let's go to solve this question. Question is a sample analysis of examination results of 200 MBAs was made. We have a 200 and this way now n is given. Should I go for t-test or z-test? Let's go for that. It was found 46 students had failed. They are not talking about the sample or population standardization. They are giving me categories. Failed, third position, second position, first position. So definitely it's a categorical data. Now class, I'm discussing two different type of question. In first question, I have discussed with you when observed data is given to me, then how to apply the chi-square. Now I'm telling you if categorical data is given to you, how to apply the chi-square test. Okay. So they are saying 46 students failed out of 200, 68 got third position, 62 first position, rest is in sorry 62 got second position, rest were in first position. That are these figures agree with the general examination result, which is in the ratio 4, 3 to 1 for various categories respectively, and they are using the word categories also. So in this case, null hypothesis, you know, that will be as it is, that the general examination result, which is in the ratio of various categories. Till this point, your statement will be as it is. Alternative, the general examination is not. Okay, so you can write it by yourself with how to take the null hypothesis and how to take the alternative. Again, I'm repeating. Null hypothesis means this statement you will take. The statement is the general examination result, which is in the ratio of for various categories, and alternative opposite of this one. Okay, so let's start to solve this question. What are the categories are given to me? Categories are failed, third position. Solve this question with me because it's a different question. We have second division and first division. Done? Okay. Then observed frequency. How many students are failed? 46. 68 got third position, 62 got second position, rest is 24. 200. How to got rest class? Just add 46, 68 and 62. Whatever the answer you are getting, subtract with 200. Okay, you will get 24. Okay, next. Now we want to calculate expected. Okay, now here expected is not total by number of observation. No, why? Because generally they are giving me ratio 3 to 1 for all the exams. And what is the 4, 3, 2 ratio? Total is 10. So how to find expected for the failed student ratio is 4. 4 by 10. Total student 200. This is 80. Third division ratio is 3. 3 by 10 into 200. 60. Then 2 by 10 into 200. It's 40. Because categories are given to me, that's why I'm discussing in this way. In the previous question, categories were not given. They have given me data in an observed way. Observed data was given to me. 1 upon 10 into 200 is equals to 20. That it's my expected frequency. I need to calculate observed minus expected whole square. Now 80 minus 46. Then whole square we are getting 1156. 64 because 68 minus 60 we are getting 8. 8 square 64, then 484, then 16. Last, observed minus expected whole square divided by expected. So 1156 divided by 80, so 14.45, 1.067, 12.1, 0.8, and total is 28.417. So my chi-square value is 28.417. Means this much observed and expected are close to each other. But let's suppose you want to cross verify your hypothesis true or not. So n is 4, done. So degree of freedom is 3. Now for 3 degree of freedom, At 5% of level of significance, what is the table value? 7.815. So tabulated value of chi-square at 5% level of significance for 3 degree of freedom is 7.815. So your calculated value is 28.417. Your calculated is greater than tabulated. Reject your null hypothesis. So in this way, guys, you can solve any question which is related to chi-square test. Thank you.